introduce him. He's Michio Kaku, who's a professor of theoretical physics at the City University of New York, who's actually co-founder of string field theory, and I know you were reading about that. And Michio is the best-selling author of several widely acclaimed science books, including Hyperspace and Physics of the Impossible, and those were the basis of his Science Channel TV show, Sci-Fi Science, which you and I watch.
Right. But now he's got a new one that's going to tell us about the future.
He has got a new book, which we both read, and it's called Physics of the Future, How Science Will Shape Human Destiny in Our Daily Lives by the Year 2100. And without further ado, I want to welcome to Conversation Crossroad, Michio Kaku.
Well, glad to be on.
It is such a delight to have you on, Michio. I personally am fascinated by the unknown and things that are yet to be. And you have a wonderful way of making concepts found in movies like Star Wars and Jurassic Park a reality. Like, these things are really in the works, that we're going to experience some amazing things in the not very distant future.
Yes, I've had the rare privilege of having a front row seat in the sense that I've interviewed over 300 of the world's top scientists for BBC Television, the Discovery Channel, the Science Channel, and my own national radio show. So I'm like a kid in a toy store talking to the people who are inventing the future. These are the people that are designing the computers of the future, the robots, the internet, medical therapies, breakthroughs, and I just get to sit and relax and let the future come at me.
It must be fascinating to spend that much time with people who are doing such breakthrough technology work.
Yes, and these are the people who are actually designing these things. You know, I'm not a science fiction writer. I read science fiction, but I'm a physicist. And we physicists say that unless you have a prototype, unless you can demonstrate that it's consistent with the laws of physics, don't bother to talk to me. And so in my book, I make literally hundreds of predictions for the next 20 years, 50 years, the next 100 years, based on actual prototypes, totally consistent with the laws of motion and the laws of physics, which actually exist in the laboratory, things that'll blow your mind away.
Well, why don't we go through some of those?
Let's blow some minds away.
Okay, for example, people want to know, how will I communicate on the Internet in the future? Well, the Internet of the future is going to be inside your contact lens within about 10, 15 years. You'll blink and you'll go online. Your contact lens will recognize people's faces, display their biography next to their image, and translate from Chinese or German into English with subtitles beneath what they say. So if you're looking for a job at a cocktail party in the future, you'll know exactly who to suck up to at any cocktail party.
So the universal translator is here, is that it?
That's right. And in addition, the first people to line up to buy these Internet contact lenses will be college students studying for final examinations. They will essentially blink, and all the answers will appear in their contact lens.
So I teach college as well, and so it means that we're going to have we'll have to have people look to see whether or not anybody's wearing contact lenses, and you're not allowed to wear the contact.
Or else
we
physicists, right? Or else we professors are going to have to stress concepts and principles rather than drudgery and memorization, which they'll do by simply blinking on their contact lens. And by the way, the second people to line up to buy these Internet contact lenses will be architects and artists. They will essentially wave their hands in the air, and beautiful sculptures, beautiful works of art will emerge in their contact lens, and later they'll print them out with a laser plastic three-dimensional printer. And so if you're an architect today and you have to move towers and move rooms around, it's painful. You have to redesign the entire building. In the future, you'll simply rearrange everything with your fingers in your contact lens. And by the way, the military is not to be left out. They're spending millions of dollars perfecting these things. I took a film crew down to Fort Benning, Georgia, And I actually had a demonstration of the military's version of this. It's an eyepiece that you put on your helmet. You flick it down, and it goes right into your eye, and you see the entire internet of the battlefield. Friendly troops, enemy troops, airplanes, all laid out for you right in your lens. This is big. This is going to be really big.
That's huge. And as you were saying that, Michio, will folks have the ability, especially when you mention contact lenses, to be able to toggle back and forth between, let's say, blinking on the internet and seeing what's in their immediate surroundings?
That's right. This is called augmented reality. This is not virtual reality. Virtual reality is for children, when you see basically animations of aliens and monsters inside your classes. This is imposing upon ordinary reality the information of virtual reality. Let's say you're a tourist and you walk through the streets of Rome today. There's really not much of the Roman Empire left. It's a very big disappointment for a lot of tourists. However, in the future, you'll see the entire Roman Empire resurrected in your contact lens as you walk through the streets of Rome. So, in other words, we're talking about augmenting reality rather than replacing reality with animation and video games. And everyone is going to use these things. If you're an astronaut, you'll be able to make repairs. You'll see schematics in your contact lens as you make repairs. If you're a fighter pilot engaged in a dogfight and the enemy goes underneath your feet, you know you're dead meat. Well, you can put a camera underneath your airplane to shoot the image into your contact lens, so you will have X-ray vision. You'll be able to see right through your own feet, beneath your feet in a dogfight. So I tell you, man, the implications of this are enormous. In the future, all of us will live in augmented reality. We'll blink, download any movie, understand what we are looking at, have annotations of people's biographies, subtitles, universal translation, all of it just by blinking.
That is amazing.
And if you can't wear contacts, they'll do it on glasses, I assume.
That's right. You have a choice. You could either do it in a jeweler's lens, you could put it on your hat, or you could put it on your glasses with an eyepiece, or you could put it in your contact lens. I tell you, man, this is big business, and a lot of companies are looking at this very seriously, because this could be the way we will access the internet of the future. And beyond that, we'll simply talk to things, and the internet will respond to us. For example, your car. Already Google is spending millions of dollars perfecting the driverless car. So you'll get into your car, talk to it, tell it where to go, and by GPS, it'll navigate through streets. The car fender will have radar to detect obstacles, and it's actually safer than a human, because humans fall asleep, humans have road rage, humans get distracted, and the robot chauffeurs don't.
Betty Lynn is looking at me, Michio, and saying, yep, you've got road rage. You need to be around when this stuff happens.
Right.
This is sort of a sophisticated, those vacuum cleaners that go around the house and get things. This is the next version, or several versions later?
Yeah, well, we're way beyond these vacuum cleaners. Okay, if you want to redecorate your house, for example, it's very painful having to, redo the wallpaper and paint the walls. In the future, the wallpaper will be intelligent. Already, big manufacturers are making intelligent wallpaper. You simply talk to the wallpaper, it changes color, it changes design. So if you want to redecorate your house,
oh my gosh,
you simply talk to the walls, and you could put screens, you can put windows, whatever you want, simply by talking to the walls. This is called OLED technology, organic light emitting diodes, basically transistors made out of flexible plastic. So in your wallet, for example, instead of having pictures of your family, you will have motion pictures of your family. You'll simply be able to take a picture, fold it up, put it in your wallet, and have full animation, full motion inside objects inside your wallet. Now, the point I'm raising is that computer chips will only cost a penny in the next 10 years. Penny, that's the cost of scrap paper. So computers will actually be cheaper than bubblegum wrappers within the next 10 years because of something called Moore's Law, which says a computer power doubles every 18 months. And so wherever you see paper today, you will see intelligence in the future. So, for example, if you want to see a doctor, today it's really like pulling teeth trying to get an appointment with a doctor, right? In the future, you simply talk to the wall. An animated version of a doctor will appear. He'll speak semi-formal English to you, not totally colloquial English. And 95% of all the questions you ask will be answered by the doctor in the wall. This is called RoboDoc. You also have robo-lawyers that will answer most of the legal questions.
That's funny you said that because Betty Lou is by career an attorney. So as you said that, I could see her mind thinking of this.
I'm actually sort of looking forward to it because it would take away the nitty-gritty kind of stuff that you don't really want to do and leave you to do the more creative and esoteric things.
Right. And, people are complaining about the high cost of health care, but realize that 95% of what happens between you and a doctor can be done between you and an animated software program that looks like a doctor and talks like a doctor, so you can reduce medical costs. Also, legal costs can be reduced. We can do a tremendous amount of savings. But for sophisticated medical analysis, you're going to have to talk to a human. And if you're in the middle of a divorce, you want to talk to a human, not a software program.
But I'm
so for delicate things, yeah.
But no, what I was going to say, though, is I'm also thinking of the folks who don't like to go to the doctor, avoid doctors and dentists all the time. This is a great way in the privacy of your own home to have the kind of technology that says, hey, listen, while you were shaving, I think I detected a problem in your left lung or whatever it might be. That is huge in terms of people's individual privacy and the ability within your own home to detect things you've got to go to a doctor's office to find out.
That's right. And the future cure for cancer, get this, the cure for cancer is going to be in your toilet. Your toilet will have what are called DNA chips, complements of Silicon Valley, which detect proteins emitted from maybe 100 cancer cells 10 years before a tumor forms. So in other words, your toilet could be the cure for cancer. The word tumor could literally disappear from the English language. You know that today, Aretha Franklin has pancreatic cancer. Steve Jobs of Apple Computer has pancreatic cancer. Usually, you don't live much more than 2 to 3 years because it's thought to be an aggressive cancer. But we now know that's not true. Scientists have sequenced the genes now of pancreatic cancer, and we realize that it's a slow-growing cancer taking up to 20 years to grow, but you only feel it in the last 2 years. That's where this comes in. In the future, your toilet will tell you that you have pancreatic cancer, and you have 20 years to get rid of it. This is big. Compliments of Silicon Valley.
Now, what impact will that have on life expectancy?
Oh, well, we're talking about increasing life expectancy for another reason. We are now beginning to tease apart at the molecular and the genetic level the basis for aging. We now know what aging is. We now know where aging takes place, but we can't cure it yet, of course. We now know what aging is. Aging is nothing but the buildup of error, genetic error and cellular error inside your cell. And we even know where it takes place. Take a car. Where does aging take place in a car? It takes place in the engine, right?
Correct.
That's where you have oxidation, moving parts, buildup of deposits, right? Where is the engine of a cell? The mitochondria. So we even know where the engine of the cell is, where aging takes place. And in animals, you realize that we could double their life expectancy already today. Yeast, insects, spiders, rabbits, dogs, cats, and now monkeys for the first time, we are literally doubling their lifespan. And we're now trying to find the genes that control that process. This is big, man. This is really big.
Well, what do we do? What do we do with the fact that we can have all of these very healthy people around for what are 200 years or something like that, much longer than we have now? What do we do with the downside of that, which is the potential for overpopulation?
Well, actually, reality shows the exact opposite, that when people live longer and are more prosperous, they have fewer children. Japan, for example, the average family has 1.2 children per family, followed by the Austrians, the Swiss, the Germans. And so we're actually seeing a collapse of the population in Japan. The death rate and the birth rate flipped last year. It's the first time it's ever happened to a developed nation. And so we actually have a situation now where people prefer to have fewer children. So as people live longer, they have fewer children. The problem is underpopulation, not overpopulation.
Well, that's true if you have prosperity goes evenly across all countries. And we've never seen that.
Well, yes and no. When a peasant has 10 children in the countryside, that's because he does a calculus. He realizes that every child he has makes him richer, more hands in the field, and more retirement benefits when he's old. But when he urbanizes, even if he's poor, he realizes that every child makes him poorer. More food, more rent to pay, more mouths to feed, and the calculus flips the other way when he urbanizes. Therefore, population and fertility rates drop like a rock, even if you're poor, once you urbanize. And once you become middle class, it drops even further, down to 1.2 children per family. And so even in Bangladesh, a country which is very poor and not even urbanized, their fertility rate is going down because of the education of women. So there are three factors involved: A, education of women; B, urbanization; and C, the growth of a large middle class.
And let's hope that we do have all of those three.
Yeah, but it does mean that we don't have to necessarily fear the fact that we're going to live longer in the future. Already, as I mentioned, we're teasing apart the genes that control the aging process in animals and realize that we are 98.5% identical to a chimpanzee in our genes, but we live twice as long as a chimpanzee. And yet only a handful of genes separate us from the chimpanzee. And we're now isolating all those genes that separate us from our nearest evolutionary neighbor, among them the gene that doubled our lifespan.
And while we're... Go ahead, Betty.
That works so... And that's really exciting because there are enough medical advances to make the last 70 years, if you wanted to, profitable and a good time, as opposed to what can happen, which is the slow, long deterioration of people. We want to be able to have people living longer with a quality of life that they would appreciate.
That's right. There's a famous myth, a Greek myth. Eos was the goddess of the dawn who was immortal, and she fell in love with a human who, of course, is immortal. So she pleaded with Zeus, the king of the gods, to give her boyfriend, a human, immortality. So Zeus granted the gift and made the boyfriend immortal. However, she made a big mistake. She forgot to ask for eternal youth as well as immortality. So the boyfriend got older and older and more decrepit. He began to fall apart, decay, deteriorate. He could never die. So the point here is we have to have eternal youth as well as eternal life. And we are going to replace those organs as they wear out. Today, from your own cells now, no rejection mechanism, we can grow bone, skin, cartilage, noses, ears, blood vessels, heart valves. The first bladder was grown 5 years ago. The first windpipe was grown a year ago. The first liver will be grown within maybe 5 years. So for you alcoholics out there who can listen to this interview, take heart. We will grow livers within perhaps about 5 years. Hang in there.
Yes, well, let's hope we're not helping people to do things that are not healthy for themselves. But it would be. I do have some friends actually. I have two people I know who are on the heart transplant list, and one who's on the double lung transplant list. And it would be truly exciting to be able to say you no longer have to die or deal with that issue of potentially dying while you're sitting on a list, as opposed to I can create that out of my own cells. That is just unbelievable.
Yeah, this is huge. Organ failure in the future will not be the reason to die in the future, because we'll simply grow organs as they wear out in the human body. This is coming very fast. It's called tissue engineering. And in mice, we could even do better than that. In mice, scientists have grown an entire beating heart from scratch. This is amazing. In fact, there's even a video. You can download the video on the web. You can actually see the heart get bigger and bigger until it forms a perfect mouse heart, and it starts to beat. I mean, you almost feel like a god watching this video of how you can grow a beating mouse heart from scratch. And also, take a look at the question of spinal cord injury. Christopher Reeve was the handsome actor who played Superman, who died because his spinal cord was severed. In mice and rats, we can partially cure that problem now. There's another video on the web where you see a mouse whose spinal cord has been severed. The hind two legs cannot walk at all, so the front two legs drag the hind two legs. But then, after using stem cell therapy, you can actually see the rat walk on all four legs in an awkward way. This is almost biblical. I mean, watching a rat walk from scratch using stem cell technology, it's almost like a scene from the Bible.
You know, I hear you talk about these things, Michio, and it just astounds me because it's the stuff years ago of sci-fi, but it's the reality of all these things that will come to be, and you're not talking, centuries away.
That's right. We're talking decades. So some people say, well, why can't I get an artificial heart now? Well, they don't exist yet. However, it's coming very fast, and in the coming decades, we will definitely see this enter the marketplace. So people can literally grow replacement organs as they wear out. And so organ failure will not be a reason to die in the future. Now, I have to be very clear about this. We do not have the fountain of youth. Don't believe all the charlatans, quacks, and people out there advertising the fountain of youth. We don't have it. The point is that we are actually seeing the genetic basis now of the fountain of youth being unraveled. And this is new. We were clueless 10, 20 years ago about this process, and now we're beginning to actually look at the genetics behind them. So, for example, if you feed an animal 30% less, it lives 30% longer. But who wants to eat 30% less? We've now found a gene that partially controls that process. It's called SIR2, SIR2. It was featured on the Oprah Winfrey Show. It's been featured on 60 Minutes. Don't believe the hype. It's not the fountain of youth. However, it's probably a part of the future fountain of youth. So we're now actually making real, tangible, reproducible, testable, falsifiable results in the laboratory that can be duplicated in any lab on Earth. This is big.
So what we'll be able to do is to deal with with cancer. We'll be able to deal with tumors. We'll be able to deal with that. How about the common cold?
Well, that's hard because there are 300 varieties of the rhinovirus, and it's not economical to create a vaccine for each and every one. Now, when I say that we're going to cure cancer, I don't mean we're going to cure every single cancer, just like we can't cure every single rhinovirus because there are too many of them. But I think we will be able to cure most of them. Now, we mentioned detection of cancer in your toilet, so we'll not even have to worry about tumors in the future. But what happens if you do get cancer? Now we have something called nanoparticles, which are smart bombs, which zero in on individual cancer cells and kill them. This is also huge because chemotherapy today is horrible, absolutely horrible. Your hair falls out, you vomit, you feel miserable every day. That's chemotherapy. That's because it's like a shotgun. Now we're creating smart bombs called nanoparticles, molecules that zap cancer cells. Now, if you take a cancer cell and compare it with an ordinary cell has round, small holes that are pores, small, round holes. Cancer cells have raggedy, large holes on its surface. You can manufacture a molecule which is halfway between those two holes. So it's too big to fit in an ordinary healthy cell, but it flows right into a cancer cell, killing it with chemicals. That's how you do it. We can now zero in on individual cancer cells because they have large raggedy holes on the surface, and you can design molecules which will fit right in with poisons which will zap the cancer cell. In one test, it was 90% effective against tumor cells. And again, it's still in its infancy. Don't expect to have this tomorrow. But the very fact that we can even have a conversation like this is absolutely amazing.
So will we also be doing designer medicine? I mean, they'll take your genetics and be able to determine exactly what it is may be more appropriate for you than it would be for me?
Yes. Right now, to sequence every single gene in your body costs $50,000. Originally, it cost $3 billion to sequence the first human's genes. And within a few years, many people say it'll cost about $1,000 to have a CD-ROM with all your genes on it. A few years after that, it'll cost about $100, in which case all of us, maybe even in our credit card, will have every single gene in our body listed, which is an owner's manual for your body. Now, I had my genes sequenced, most of them. BBC Television took some of my blood, sent it down to Vanderbilt University in Tennessee, sequenced it, and, gave me a CD-ROM with most of my genes on it. And I wanted to know, because my mother died of Alzheimer's, and there's the APOE4 gene, which predisposes you genetically to have Alzheimer's, and you can actually test for it. So BBC Television put a camera in my face and asked me, okay, we're now going to tell you whether or not you have the gene which predisposes you to Alzheimer's disease.
How did you feel about that while that was going on?
Well, as the camera was turning, the doctor announced that I did not have that particular gene, and then they wanted to know my response. And my response was that the anxiety I was feeling will be duplicated by millions of people around the world when they get the verdict as to whether or not they have the cystic fibrosis or Tay-Sachs or sickle cell anemia gene, because those are the diseases that affect Northern Europeans, Jewish people, and African Americans. And so the anxiety I felt will be the same anxiety that almost everyone will feel when their genes are available for $100.
Will we also be looking at things like, I have a nephew who has schizophrenia, and the suggestion is that the underlying gene is perhaps expressed when there's some sort of an environmental effect that shows up. Will we be able to do those kinds of things? Identify the underlying? Okay, go ahead.
Yeah. You see, certain things are based on one single mutation in one single gene. As I mentioned, cystic fibrosis if you're from Northern Europe, Tay-Sachs if you happen to be Jewish, or sickle cell anemia if you're African American. These are things you have to worry about, and we will cure them because they are caused by a single mutation in a single gene. Other things are multigenic, like schizophrenia, heart disease. For example, you can have identical twins, one of whom is schizophrenic and the other one is not. Therefore, bingo, you know immediately that one gene cannot possibly cause schizophrenia, or else twins would have 100% correlation between identical twins. So it means that it's probably multigenic. Many genes from inherited from your parents are responsible, plus some cues from the environment that set it off. So certain things will take a lot longer. We're going to have enormous breakthroughs in diseases that are caused by single mutations, but it's going to be an awful lot slower dealing with diseases that involve more than one gene.
Michio, in your new book, Physics of the Future, you talk about the concept of designer children.
Mm-hmm.
And I wonder if you could go even a little bit more into that. The whole concept of designing your offspring has some pretty incredible implications to it.
Oh, sure. I mean, you realize that today, parents do almost everything to monkey with the evolutionary success of their kids. They give them tennis lessons, violin lessons, tutoring, dress them up in bizarre clothes, everything to make them successful in the real world. Think of what's going to happen when parents get a hold of the genetics of their kid. Look at the human growth hormone. It's a fad on the internet. You know, parents want human growth hormones, so they don't want their kids to be, quote, stunted, unquote. And they're already messing with the height of their kids. So you can imagine what parents are going to do when they have the genetics of the kid. Now, there are two genes that are very important here. One is the smart mouse gene, which has been isolated. The smart mouse gene actually makes mice smarter. They have better memory, better coordination. They remember things much better, and they can seek food out much quicker, and they learn much faster. That gene has been isolated. And there's also the mighty mouse gene, the gene that bulks up young mice, making them muscle-bound. There was a young boy in Germany who had the mighty mouse gene. He was muscle-bound. So scientists cannot call it the mighty mouse gene anymore, so they call it the Schwarzenegger gene now. Now, the Olympics have to worry about this. This is huge because it turns out it's very difficult to tell whether you've been doped up with the proteins involved in the mighty mouse gene, while it's easy to tell whether or not you're on steroids. So the Olympic Committee has already set up a study group, one of my friends is on it in fact, to analyze future doping tests on the Olympics. And this could go into professional sports as well. In the future, we may have to get used to the fact that your team has not only the best coach that money can buy, the best play area and rehearsal area that money can buy, but also the best geneticist that money can buy, because in the future, sports teams may be enhanced genetically, and it's very difficult to prove who is enhanced and who isn't.
You know, the beginning of this process, when people could identify with sonograms what the sex of a child was, had some real downsides to it.
Yeah, take a look at India and China. It's created a gigantic demographic earthquake. You can go to villages in China and India, especially far away from the cities, where the imbalance between boys and girls is huge. And it means that these kids are now coming of age, and it's going to create enormous disruptions in the Chinese and Indian economy. Many people fear it's going to cause a tremendous amount of prostitution, sexual trafficking and slaves. It could be nasty because of the huge imbalance that peasants want to have with the sonogram. So ironically, peasants will have boys as children, but they will probably have no grandkids at all because there's no one to marry their children.
It's extraordinary. The downsides, or I should say the unintended consequences of social behavior is just amazing.
Right, and I think personally, laws at some point may have to be passed to regulate this. Now remember, the technology for designer children does not yet exist. However, you can see it coming, because already with mice, already with animals, we can design them in ways that will actually shock you. So in the animal kingdom, we've already done it. So with humans, because it's more difficult to do trials and testing on humans, designer kids do not exist. However, it's coming. And laws will probably have to be passed to regulate it, to make sure that, anxious parents don't go crazy. Now, there's also going to be peer pressure, because if your kid has to compete against another child who is rumored to be enhanced, then there's going to be pressure on you to enhance your kids as well. And so that's something to think about in the future, social pressure, because your kids will compete in the marketplace against other kids, some of whom may be enhanced.
Well, and I think that we're all hardwired to want the best for our children. Now, the definition of what is best is always the difficult thing here, but I can see where people would really want to make sure that their child is the smartest their child could be. I mean, they spend hundreds of thousands of dollars now sending them to the right prep school or the right daycare center so that they can get to the right preschool so that they could then get to the right this, to the right that.
Right. Now, I think parents, instead of worrying about trying to genetically enhance their kids to make them prettier or more handsome, they should really try to train their kids to be suited for the job market of the future. I think that's what parents should really do, is be concerned about the jobs of the future rather than whether or not their kid has blonde hair or whatever. So in my book, I have a whole chapter on the economics of the future, which jobs are going to thrive, which jobs are doomed, which nations will rise, which nations will fall, because the economy itself is now gradually making a change. And so that's where I think parents can really make a big dent to make sure that their kids are successful in life.
Well, I can see a big responsibility on the part of the parents is knowing what the physics of the future implies, and how do you, like you said, Michio, point your children in the right direction, because one of the downfalls of being a parent is not having all the answers and not being tuned in to what the very next generation will have to deal with, especially in the economy, especially in the job market. I see a huge Grand Canyon just between my generation and my kids.
Yeah, the previous generation of educators talked about a digital divide, the fact that some people will have access to the internet and other kids won't. Well, that's a bunch of nonsense, because kids today, almost everyone's wired up, or at least tries to get wired up, because there's peer pressure. Access is not the problem. It is dirt cheap now to get online or to know somebody who will get you online. The problem is not access. The problem is not the digital divide. The problem is the job market, because the job market is changing dramatically. And the job market is changing from commodity-based capital to intellectual capital. For example, Tony Blair used to boast the fact that England derives more revenue from rock and roll and rock music than it does the coal mining industry. And when you think of a British worker, you think of a coal miner, right? And yet rock and roll generates more revenue for England. Rock and roll is an example of intellectual capital. We're talking about creativity, analysis, software, telling a joke, writing a book, doing a science experiment, designing a computer, things that involve the creative, innovative mind, versus commodities like food, which are getting cheaper and cheaper every year. This morning, you had breakfast that the King of England could not have had 100 years ago. Delicacies from around the world, better containerization, shipping, mass production, competition is driving the cost of food to the point where food is dirt cheap, which means that nations which put all their eggs in agriculture will probably see their economies turn to dust in the future, while nations like China that understand that you have to use commodity capital to leverage the second stage, which is intellectual capital, those countries will survive. For example, the best students from China, where do they go? They come to the United States, where I see them. 50% of all PhD candidates in the United States are foreign-born, many of them from China, because China realizes that it has to get a high-tech sector off the ground as well. So in my book, I list the jobs, blue-collar jobs, white-collar jobs that will thrive in the future, and those jobs which will be obliterated in the future the same way that blacksmiths and wagon makers no longer have a job today.
That is so incredible. And I think, based on what you just said, one of the beauties of your book, Physics of the Future, it's not only the fact that you've brought future developments to the level of every person's understanding, but there's a part of the book that really is a how-to guide, what to look for, how to deal with it, how to communicate it within your own family.
That's right. I tried to break it down to real person's real life experience rather than, talking about the clouds. Like a day in a life. What will a day in a life in 2050 look like? What will a day in a life in 2100 look like? How will we communicate with our friends, relatives? For example, some people fear the future because they don't understand it and they think they're going to be left behind. That's sort of like the first stage when you encounter these technologies in my book. Then the second stage is you get used to it. The second stage is you begin to realize this is useful. I mean, think about it, being able to communicate with anyone in the world, being able to search for every piece of information by blinking. People think it's useful. And then the third stage is, I knew it all along. I mean, I invented it. I mean, of course, any idiot knows that, right? And so, same thing here. People feel afraid of technology because they don't want to be left behind. But once they realize how useful it is and the fact that their kids already use this technology, then they say to themselves, of course, yeah, it's inevitable.
Well, it really is true that you learn so much from your children who have this open approach to technology, and they just greet it and love it, put their arms around it, and they're ready to go. And we who are older will sit back and say, well, I'm not quite sure. How does this go? This is a little uncomfortable. How can I get it? And then once you get used to it, you do indeed say, oh, well, that was easy. Let's do some more.
That's right. And remember when the telephone first came out over 100 years ago? People were really afraid of it. You know, they criticized it by saying that people are not going to have dinner table conversations anymore. Instead, they'll talk to this mysterious, disembodied voice, this voice from outer space, right? Well, the critics were absolutely right. We don't necessarily talk to our relatives so much anymore, and we love it because our circle of friends increased by 100 times once we got the telephone. Now, kids today play video games with other kids in Russia, South Africa, without even thinking about it. They can set up a game with somebody in Australia. Their circle of friends has increased by a factor of 1 million times because of the Internet. So, you see, even though technology was originally conceived of to be very male-dominated and hierarchical, eventually technologies become female. That is, they're about touching people, making contact with people, making friends. And that's why the Internet started off as a war-fighting device created by the Pentagon, is now basically about touching people. You know, if you're like an old lady in an elderly home for a nursing home, you know, it used to be that you would just be lonely and cry every night. Now you can just get on the Internet and play bridge with people from all over the world. So it's really explosively expanded people's level of contacts with other people.
And definitely a quality of life enhancement, like you were saying. There's so many more opportunities to feel vital and vibrant and connected, no matter what your age.
And the psychologists say that if you connect with people, then you're much less likely to see them as the devil incarnate, and it prevents or helps to prevent things like wars and misunderstandings and the rest of that. So here's to technology getting our children and ourselves to deal with people we think might be a little strange.
Right. And speaking about wars, if you take a look at all the wars we've learned about since we were in elementary school, they've always been between monarchies and dictatorships, but never between two democracies. No two democracies have ever fought a major war with each other throughout history. And the Internet is a democratizing force. Just look at the Middle East today. And so it means that in the future we will still have wars, but the fires which drive these wars will be lessened because democracies don't war with other democracies. And so I think this is a very positive development, the fact that understanding, empowerment, knowledge between peoples makes it difficult for dictatorships to start wars in the future.
That's wonderfully reassuring, too, in looking out toward the future, because you always wonder, you know, the popular saying, are we just going to end up killing each other, you know, and blowing up the planet? But the fact that you're saying that the Internet is so democratizing is a wonderfully reassuring point.
Right. In fact, I mentioned at the end of the book that by the year 2100, our civilization will make the transition to a Type 1 civilization. We physicists rank civilizations in outer space by energy consumption. A Type 1 civilization is a planetary civilization. They control the weather. They can play with earthquakes and volcanoes. Anything planetary they control, like Buck Rogers or Flash Gordon. Type 2 is stellar. They can actually manipulate entire stars, like in Star Trek. And then Type 3 is galactic, like the Empire of Star Wars. On this scale, we are type 0. We're not even on this scale. We get our energy from dead plants, oil and coal. But we're about 100 years. You just get a calculator and you just calculate it. That we're about 100 years from being type 1. And that's where we're going. Every time I open the newspaper, I see the birth pangs of the birth of a type 1 civilization. For example, what is the Internet? That's the beginning of a type 1 telephone system. What is English? That is the beginning of a type 1 language. What is the European Union? That's the beginning of a type 1 economy. And why do they exist? To compete with us. We are NAFTA. And what is the Olympics and soccer? The beginning of a type 1 sports. What is rock and roll? The beginning of a type 1 youth culture. And so we're beginning to see the birth pangs of a planetary civilization that is educated, multicultural, scientific. But there are forces that resist that, the forces of chaos, like nuclear proliferation, designer germ warfare. If somebody, for example, takes AIDS and weaponizes it by making it airborne, you can literally destroy 99% of the human race with airborne AIDS. And so these are things that we have to worry about. But overall, I'm optimistic that we will attain type 1 status around the year 2100.
Only a physicist could deal with it as a planetary or stellar. I mean, it's an amazing ability that as a physicist you're looking at it from the huge dimension of the galaxy and the universe and honing it down to our one little planet, as opposed to us who look at it on the day-to-day basis at this very micro level, sort of a nano level in comparison.
Yeah, that's right. And the reason why we do this is because we physicists do scan the heavens looking for signs of intelligent life, and we realize that 1 million years is nothing but a blink of an eye compared to the 13.7 billion years of the universe. And therefore, if any intelligent life out there exists, we physicists have to rank them. One day we will make contact with extraterrestrial civilizations, and we're going to have to rank them. We're going to have to know exactly how advanced are they. And we rank civilizations by energy consumption. And on that scale, you begin to realize how humble we are, because we're not even on the scale of planetary, stellar, and galactic consumptions of energy. But I mention this because sometime in this century, we may also make contact with intelligent life in outer space. And we physicists have already prepared for the day when we do make contact by trying to analyze what kinds of civilization are possible in outer space. And on that scale, you begin to realize that 2100 really is an important date. That's the date when we will attain planetary status, and we will be a planetary civilization. And every time I open the newspaper, I can see the birth pangs of type 1 everywhere in the newspaper.
Well, I'm looking forward to living a long and much healthier life and being able to deal with whatever comes in, what technology brings us as new either problems or benefits to us. It'll be a fascinating future.
And Michio, we can't thank you enough for taking time out of what is, I know, an immensely busy schedule to talk with us today and to share just a bit of what's in your new book and what's coming down the pipe in the future.
That's right. And, I've made hundreds of predictions in the book based on interviews with 300 of the world's top scientists. And in this interview, you just got a taste of the predictions that are going to change the life of our children and grandkids. And maybe some of us will live to see it, too.
Well, I hope you find a way to clone yourself for multiple generations, because the way that you take such intense knowledge and not only make it palatable but exciting and easily digestible is beyond a reflection of your own learning and experience. It is truly a gift.
Well, thank you very much. And the book, by the way, is a New York Times bestseller now. So a lot of people want to find out about their future.
I encourage all Conversation Crossroad listeners to pick up not just one copy, but pick up a copy for all your immediate family members, friends. We've been talking with Michio Kaku and his wonderful new book, is called Physics of the Future, How Science Will Shape Human Destiny and Our Daily Lives by the Year 2100. It's available online and in all the major bookstores, and I would challenge you to go into any bookstore and not be impressed immediately by the fact his book is on display as soon as you go in, so you can't miss it. Pick up a copy. You will read it multiple times and love it.
Yeah, as a matter of fact, you can pick up the book and read it, and you can read it in pieces, and it makes it really fascinating to spend a little time letting it digest in your brain as you're going through it. The future is fascinating, and we're going to be really, I think we're going to have to wait until 2100, Michio, to give you a grade on what your predictions came out at.
Right.
So we'll meet you there, 2100.
And as Michio was saying, we just touched on a very few of the topics that are in the book. This book is packed with things that will thrill and excite you.
Or as my kids say, this rocks.
Any final words for the audience, Michio?
Well, just that instead of relying upon science fiction and writers and historians and sociologists, who do a good job, by the way, why not listen to the scientists themselves who are actually creating the future in their laboratory? Why not get the real thing rather than the speculation of a writer or a speculation of a historian? Why not find out from the horse's mouth exactly what's coming down, which is going to change everything?
It's been a fascinating hour. Thank you so much, Michio. We appreciate your time, and we wish you the best of luck continuing luck on the book.
And we will see you definitely in the future.
Okay. Talk to you later.
Talk to you later. We've been talking with Michio Kaku, and again, the book is Physics of the Future. And on behalf of Betty Lynn and I, have a wonderful day and an even greater future.
And if you can't wear contacts, they'll do it on glasses, I assume.
That's right. You have a choice. You could either do it in a jeweler's lens, you could put it on your hat, or you could put it on your glasses with an eyepiece, or you could put it in your contact lens. I tell you, man, this is big business, and a lot of companies are looking at this very seriously because this could be the way we will access the Internet of the future. And beyond that, we'll simply talk to things, and the Internet will respond to us. For example, your car. Already Google is spending millions of dollars perfecting the driverless car. So you'll get into your car, talk to it, tell it where to go, and by GPS, it'll navigate through streets. The car fender will have radar to detect obstacles, and it's actually safer than a human because humans fall asleep, humans have road rage, humans get distracted, and the robot chauffeurs don't.
Betty Lynn is looking at me, Michio, and saying, yep, you've got road rage. You need to be around when this stuff happens.
Right.
This is sort of a sophisticated, those vacuum cleaners that go around the house and get things. This is the next version or several versions later?
Yeah, well, we're way beyond these vacuum cleaners. Okay, if you want to redecorate your house, for example, it's very painful having to, redo the wallpaper and paint the walls. In the future, the wallpaper will be intelligent. Already, big manufacturers are making intelligent wallpaper. You simply talk to the wallpaper, it changes color, it changes design. So if you want to redecorate your house,
oh my gosh,
you simply talk to the walls, and you could put screens, you can put windows, whatever you want, simply by talking to any cocktail party.
So the universal translator is here, is that it?
That's right. And in addition, the first people to line up to buy these Internet contact lenses will be college students studying for final examinations. They will essentially blink, and all the answers will appear in their contact lens.
So I teach college as well, and so it means that we're going to have we'll have to have people look to see whether or not anybody's wearing contact lenses, and you're not allowed to wear the contact.
Or else
we physicists,
right? Or else we professors are going to have to stress concepts and principles rather than drudgery, and memorization, which they'll do by simply blinking on their contact lens. And by the way, the second people to line up to buy these internet contact lenses will be architects and artists. They will essentially wave their hands in the air, and beautiful sculptures, beautiful works of art will emerge in their contact lens, and later they'll print them out with a laser plastic three-dimensional printer. And so if you're an architect today and you have to move towers and move rooms around, it's painful. You have to redesign the entire building. In the future, you'll simply rearrange everything with your fingers in your contact lens. And by the way, the military is not to be left out. They're spending millions of dollars perfecting these things. I took a film crew down to Fort Benning, Georgia, and I actually had a demonstration of the military's version of this. It's an eyepiece that you put on your helmet. You flick it down, and it goes right into your eye, and you see the entire internet of the battlefield. Friendly troops, enemy troops, airplanes, all laid out for you right in your lens. This is big. This is going to be really big.
That's huge.
The world's top scientists for BBC Television, the Discovery Channel, the Science Channel, and my own national radio show. So I'm like a kid in a toy store talking to the people who are inventing the future. These are the people that are designing the computers of the future, the robots, the internet, medical therapies, breakthroughs, and I just get to sit and relax and let the future come at me.
It must be fascinating to spend that much time with people who are doing such breakthrough technology work.
Yes, and these are the people who are actually designing these things. You know, I'm not a science fiction writer. I read science fiction, but I'm a physicist. And we physicists say that unless you have a prototype, unless you can demonstrate that it's consistent with the laws of physics, don't bother to talk to me. And so in my book, I make literally hundreds of predictions for the next 20 years, 50 years, the next 100 years, based on actual prototypes, totally consistent with the laws of motion and the laws of physics, which actually exist in the laboratory, things that will blow your mind away.
Well, why don't we go through some of those?
Let's blow some minds away.
Okay, for example, people want to know, how will I communicate on the Internet in the future? Well, the Internet of the future is going to be inside your contact lens within about 10, 15 years. You'll blink and you'll go online. Your contact lens will recognize people's faces, display their biography next to their image, and translate from Chinese or German into English with subtitles beneath what they say. So if you're looking for a job at a cocktail party in the future, you'll know exactly who to suck up to at.
And as you were saying that, Michio, will folks have the ability, especially when you mention contact lenses, to be able to toggle back and forth between, let's say, blinking on the Internet and seeing what's in their immediate surroundings?
That's right. This is called augmented reality. This is not virtual reality. Virtual reality is for children, when you see basically animations of aliens and monsters inside your classes. This is imposing upon ordinary reality the information of virtual reality. Let's say you're a tourist and you walk through the streets of Rome today. There's really not much of the Roman Empire left. It's a very big disappointment for a lot of tourists. However, in the future, you'll see the entire Roman Empire resurrected in your contact lens as you walk through the streets of Rome. So, in other words, we're talking about augmenting reality rather than replacing reality with animation and video games. And everyone is going to use these things. If you're an astronaut, you'll be able to make repairs. You'll see schematics in your contact lens as you make repairs. If you're a fighter pilot engaged in a dogfight and the enemy goes underneath your feet, you know you're dead meat. Well, you can put a camera underneath your airplane to shoot the image into your contact lens, so you will have X-ray vision. You'll be able to see right through your own feet, beneath your feet in a dogfight. So I tell you, man, the implications of this are enormous. In the future, all of us will live in augmented reality. We'll blink, download any movie, understand what we are looking at, have annotations of people's biographies, subtitles, universal translation, all of it just by blinking.
That is amazing. Introduce him. He's Michio Kaku, who's a professor of theoretical physics at the City University of New York, who's actually co-founder of string field theory, and I know you were reading about that. And Michio is the best-selling author of several widely acclaimed science books, including Hyperspace and Physics of the Impossible, and those were the basis of his Science Channel TV show, Sci-Fi Science, which you and I watch.
Right. But now he's got a new one that's going to tell us about the future.
He has got a new book, which we both read, and it's called Physics of the Future, How Science Will Shape Human Destiny in Our Daily Lives by the Year 2100. And without further ado, I want to welcome to Conversation Crossroad, Michio Kaku.
Well, glad to be on.
It's such a delight to have you on, Michio. I personally am fascinated by the unknown and things that are yet to be. And you have a wonderful way of making concepts found in movies like Star Wars and Jurassic Park a reality. Like, these things are really in the works, that we're going to experience some amazing things in the not very distant future.
Yes, I've had the rare privilege of having a front row seat in the sense that I've interviewed over 300 of the